Hello and welcome to Math with Mrs. Becker. Today in College Algebra, we are going to look at section 7.7, where we get to find what is called the determinant of a square matrix. Every square matrix, and what that means is that the dimensions are the same. So a 2 by 2, a 3 by 3, a 4 by 4, okay? Anytime you have a square matrix, there is one number that is associated with that, and it's called its determinant. And the cool thing is the determinant can help you to solve systems of equations. And so that's what we will look at in section 7.8. Today, we will just simply calculate the determinant. Okay. Historically, the use of determinants arose from special number patterns that occur when systems of linear equations are solved. Okay, so for example, what they do is they're taking a system of equations, then they're taking the coefficients. Remember, coefficient means it's the number in front of the letter. So here's the values that were in front of x's. Here's the values that were in front of y's. This is a 2 by 2 matrix. Notice how they found the determinant. They took a sub 1 times b sub 2. They multiplied those. Minus a sub 2 times b sub 1. So in a way, it kind of feels like back in algebra, when you learned how to do cross multiplication, you multiply the top of the first times the bottom of the second, and then we minus multiply bottom of the first times the top of the second. And that's how you find the determinant of a 2 by 2. You guys, that's the pattern, okay? Determinant. The two ways that they'll express that they want you to find a determinant is either using the letters D, E, T, and then telling you the matrix name, or it kind of looks like absolute value bars with the name of that matrix on the inside. But both of these just mean to find the determinant. So you would take those two values, multiply them, minus, take those two values, multiply them. The difference is your determinant, okay? So let's go ahead and find this. So again, they could say this way, or they could say find the determinant of A. Okay, so either of those things just means to find the determinant. The way you do it, 2 times 2 is 4, minus 1 times negative 3 is negative 3. If you minus a negative, you're actually adding. So the determinant is called a 7, or the determinant value is a 7. Okay. Here, they could say to find the determinant of B this way. They could say find the determinant of B this way. Okay. Either way, and here's how you find it. 2 times 2 is 4, minus 4 times 1 is 4. 4 minus 4, your determinant is a 0. Okay? And some of you right now are probably thinking, are you kidding? Not kidding. This is it. Okay? The determinant of C can be written two different ways. Let's find it. 0 times 4 is 0, minus 2 times 3 halves. If you picture this, 2 times 3 halves, the 2 would cancel because you're multiplying by the denominator, so it would be a 3. 0 minus 3 is negative 3. So notice in these three examples, I wanted you to realize that it's okay for your determinant to be positive. It's okay for your determinant to be 0. It's okay for your determinant to be negative. So you could have positive, 0, or negative when you are looking at that determinant value. So this is how you find a 2 by 2. Now 3 by 3, okay, it steps it up a little bit, but to me this is more fun, okay? So what you do, if it is a 3 by 3, you take the first column and you write it on the outside. So 0, 3, 4. Then you take the second column and you write it on the outside. 2, negative 1, 0. Okay? So again, first column, rewrite it on the outside. Second column, rewrite it on the outside. Now what we do is it's going to look like we're making a fence. So you start in the upper right corner. And because it's a 3 by 3, you draw a diagonal line that goes through 3 values. And you multiply these. 0 times negative 1 times 1, well, that's a 0. Plus, now again, we start at the top. It has to go through 3 numbers. That's why we needed that 4 there. 2 times 2 is 4. 4 times 4 is 16. Plus, now again, you start from the top and you make sure you go through 3 numbers. 1 times 3 is 3. 3 times 0 is 0. Okay, so going from the top, our value is a 16. Now we go from the bottom. You do the same thing, but I start in the bottom corner. 4 times negative 1 is negative 4 times 1, that's a negative 4. Plus, now we start in the middle. 0 times 2 times 0 is 0. Plus, 1 times 3 times 2 is 6. You add those together. Negative 4 plus 0 plus 6 is 2. Now to find the determinant, it's the first value, so 16, minus the second value, 2. 16 minus 2, your determinant is a 14. Okay, so that's how you find the determinant of a 3 by 3. And again, when you're done, it kind of looks like a fence. I think it's kind of pretty. Let's go ahead and do at least one more of those. It's a little bit trickier, but not bad. If it's a 3 by 3, take the first column, write it on the outside. So negative 3, 4, 2. Now you take the second column and you do the same thing. 2, 5, negative 3. Okay, so that's how you set up to find the determinant of a 3 by 3. Now you always start in the upper left corner. So negative 3 times 5 times 1. Negative 3 times 5 is negative 15. Negative 15 times 1 is negative 15. Plus, now you go to the middle of the top. 2 times 6 times 2. 2 times 6 is 12. 12 times 2 is 24. Plus, now you go to the last one that's actually within the matrix. 1 times 4 is 4. 4 times negative 3 is negative 12. Now I add those together, and that's my first value. So I have negative 15 plus 24 plus negative 12, and I have a negative 3. So that's the first value. Now you do the same thing, but we have to go from the bottom, and you always start all the way to the left. 2 times 5 times 1. That's a 10. Plus negative 3 times 6 is negative 18 times negative 3 is positive 54. Plus 1 times 4 times 2 is 8. So now what I have to do is go ahead and add those together. So if I take 10 plus 54 plus 8, I get 72. Now to find your determinant, it's the first sum minus the second sum. So negative 3 minus 72, your determinant is a negative 75. Again, it looks like a fence. Take the first column, write it outside. Second column, write it outside. From the top, diagonal, diagonal, diagonal. From the bottom, diagonal, diagonal, diagonal. You multiply the numbers that are on the diagonal, add those values together, and then your final step is subtracting. Okay? If you have square matrices that are 4 by 4 or 5 by 5, anything higher than a 3 by 3 gets super tedious. Okay? So we won't be doing those, except for there is one exception to the rule. If you can get triangles of zeros, then it makes this determinant process so much easier. And you'll probably look at this and you'll be like, hey, this is like row echelon form and Gauss-Jordan where you want to get those zeros. Those corners of zeros also help to find the determinant. It makes it so much easier. A triangular matrix is a square matrix with all zero entries either above or below the main diagonal. Your main diagonal is always the upper left to the bottom right, okay? So that would be the main diagonal. This would be the main diagonal, upper left to bottom right, okay? If you have zeros above that, a big corner, this is called a lower triangular matrix. If you have all of your zeros on the bottom, then it would be called an upper triangular matrix, okay? But either way, if you have a corner of zeros or maybe even two corner of zeros, to find the determinant, all you do is find the product of the entries on the main diagonal, okay? That is it, you guys, that's it. So if I see here is a corner of zeros, to find the determinant, you multiply the numbers. So I would take 2 times negative 2 times 1 times 3. That's it. You multiply the numbers on the main diagonal. 2 times negative 2 is negative 4. Times 1 is still a negative 4. Times 3, negative 12. There's your determinant. Here's my main diagonal. This is a corner of zeros. This is a corner of zeros. Okay, so this one you actually ended up with both. All you need is 1. So it's okay to have it just above, it's okay to have it just below. Sometimes you get it both ways. The process is the same. As soon as you have a triangle of zeros, either above or below or both of that main diagonal, you just multiply them. So -1 times 3 times 2 times 4 times -2, whatever that is, you guys, that's our determinant, and we will be done with 7.7. And when I multiply them, this is a positive 48. Okay, so these are determinants. The reason why we find determinants is because you can use them to solve systems of equations, and that's what we will be doing in 7.8. I hope you guys enjoyed learning about determinants, and I'll talk to you soon.